Okay, so Torsten did basically, I think he did this exact question. So everybody remembers it, right? Okay. Okay.
The airplane was just a different way.
Okay, that's fine. Well, let's redo it just for practice, okay? No. Okay. Here we go. Doesn't matter.
Question, why is S equal to 10 miles, but it's 6 km? Do we have to do the conversion?
No. What do you want it to be, miles or kilometers? Okay, everything's kilometers then. There you go. Okay. An airplane passes over a radar tracking station. If S is decreasing at a rate of 400 kilometers, I guess that should be per hour. What is the speed of the plane when S is equal to 10 kilometers? Conveniently, the diagram is drawn. Basically, everything in these part 2 ones are triangles. Okay? So it's either going to be something relating angles, which is a trig problem, a right angle grade 10 trig problem, or it's going to be a Pythagorean problem. All right? This is a Pythagorean because they don't say anything about angles. Okay? So, label your triangle. I'm just going to use X, Y, and S that they have there. There's my X, there's my Y, and there's my S. Pythagoras says X squared plus Y squared is equal to S squared. Okay, at this point, you look at it. So this is like the question that was on question 2 of that sheet with the barrel, and it talked about the radius. The radius of a barrel doesn't change, right? It's constant. Is anything here constant? Sorry? The height of the airplane is constant. It doesn't say it changes, right? It doesn't say it goes up or down. It just says it's moving along like this. So this 6 kilometers is constant. Put it in the formula right away. Okay? So you get X squared plus 6 squared is equal to S squared. So there's our formula. What do I do now? Derive it with respect to time. What's the derivative of X squared with respect to time? There you go. What's the derivative of a constant? 0. So that 6 squared, or 36, goes away. It's gone. Equals what? 2s times ds dt. Okay. What are we trying to find? The speed of the plane. What represents the speed of the plane? This is our equation. What represents the speed of a plane? I've heard 2 things. Who says ds dt? Who says dx dt? Dx dt's are correct. If you're flying horizontally, your speed is relative to the ground, right? So it's how the x coordinate is changing. Okay? So this is your speed. It's confusing because they use s for it. I think they did that on purpose. I just stole this out of the book. But they want you to think about what actually is the speed. Okay, so we're solving for dx dt. So we got to get everything to the other side. So we divide off the 2x. So if I divide off the 2x, the 2's go away. So I get that. Do I know S? What is it? 10. 10 kilometers. Sorry? These 2 things? Yes. What's ds dt? 400, right? What is x? We don't know it, right? But can we find it? How? Using the Pythagorean formula. So Whoa. Find x. So we take our formula, x squared plus 6 squared is equal to s squared. I know what s is, it's 10. So plug that in, you can solve for x. Oh, 64, and then now, x, when you square root something, you get plus or minus. Does it make sense to have a negative? You can't have a negative. Yeah, but what is x measuring? X is measuring the distance here, right? So you're not going to have a negative. I mean, you could technically because it doesn't change the answer, except for positive or negative, which is a physics thing, right? But you don't want the negative distance, right? So we're just going to use 8. So x is 8. Plug that into your formula. It's 8 kilometers. I guess I should be more accurate. So 10 divided by 8 times 400 spits out 500 kilometers an hour. Is that okay for everybody? Okay. I'm not going to do the second one because it involves tan derivative, and we didn't do tan derivative. Did he say you have to know the tan derivative? We'll skip it. If we need, I'll ask him tomorrow. If we need to know it, I'll do it. I kind of want to do it, but whatever. All right, so skip to the next page, please. Yeah? Yeah. Okay, changing height. So, a construction worker is pulling a 5-meter plank up the side of a building at a rate of 0.15 meters per second. How fast is the end of the plank sliding along the ground when the plank is 2.5 meters from the building? First thing, draw a diagram. Don't try to do this without a diagram, okay? So if they don't give you a diagram, draw a diagram. Vertically. So okay, so we have a 5-meter plank? Here's our 5-meter plank. Does that change? No. Let me draw the construction worker because I know everybody loves my artistic skills. Pretty good, huh? Pretty good. Should be an art teacher. Stick figures 101. Oh, hard hat. Sorry. How do you know it's a he? Well, hard hat. There you go. That's a hard hat, isn't it? There you go. Okay. All right. So 5-meter plank up the side of a building. So we should label this as X, Y, and Z, I guess. What do you want X to be? Horizontal. That'll be Y, and this will be Z. Okay. Do I mention angles anywhere in here? No, so it's not a trig problem. It's a Pythagorean problem. Okay. Then once you write the Pythagorean formula, ask yourself, does anything stay constant? The 5, so then put that in. I'm just going to write 25. Is everybody okay with that? I can't help you then. All right. I have our formula. Whoa. Is there anything else I should put? All right. What do we do? With respect to time. What's the derivative of a constant? 0. Look how cheap these boards are. These things put another screw right there. It's not the school, it's the people that built the school. Okay. All right. What am I trying to solve for here? You're trying to find dx dt because they're asking for how fast is the end of the plank sliding along the ground? How fast is the plank going that way? So that's x changing with respect to time, right? So this is your unknown. What's dy dt? Yeah, it's being pulled up the side of a building at a rate of 0.15. So this is dy dt. All right, plug in everything you know. What else do you know? X is 2.5, right? Sorry? Okay. So plug in everything. So I get 2 times 2.5 meters times dx dt plus 2 times, do I know why? I don't know why. So how do I figure that out? Use your formula to figure out why, because we know what x is. Green. So over to the side here, we go x is 2.5 squared plus y squared is equal to 25. You solve that, you get y is equal to 4.33. So then that goes in and you get 4.33 meters. Dy dt is 0.15 meters per second. And the whole thing equals 0. So now you just have to manipulate it to solve dx dt. So negative 0.26 meters per second. Does that make sense? Yes, sir. You don't know what a winch is? You attach it and you kind of like pull it in, basically. Think of like putting a rope on something and tying it to a, what am I trying to say here?
Like a pulley.
A pulley, yeah. Like you see when boats come in, like when they onto their. Okay, that's basically a winch. All right, here we go. You want to try this one on your own? Okay. A boat is pulled into a dock by a winch that is 12 feet above the deck of the boat. If the winch pulls the rope at a rate of 4 feet per second, determine the speed of the boat when the length of the rope is 13 feet. All right, we're drawing a picture. Again, I can use different colors. Blue for water. I know. Look at my boat. My boats are awesome. Look at this. That is awesome. I know. I don't know. I should go into art school. See you later, Aiden. There's the rope, which is, how long is the rope? Well, it changes, so. Boom. Okay, let's label this. So, it is in my world. Don't question me. X, Y, and Z. What formula are we using, people? Are we seeing a pattern here? That's fine. You can do that. You just label A, B, and C. It doesn't matter. You can use any variable you want. Okay. What stays constant? Y does, exactly. Because Y is the height of the dock or the winch above the deck of the boat, right? So this is 12. That doesn't change. All right. The winch pulls the rope at a rate of 4 feet per second. Determine the speed of the boat. What am I trying to find if I say determine the speed of the boat? Yes. Speed of the boat is dx dt, right? That is going to be dx dt. That's what I want to know. What is this number? 4 feet per second. dz dt. Because the rope is being pulled in that way. All right, so what do we do? Derive. Gets a little boring after a while. That's why I want to do the other trig stuff. Okay. Okay. We're solving for dx dt, so divide off the 2x. As per usual, we got to use the original to solve for. What don't I know? X. So it's x squared plus 12 squared equals, what's z? 13. If you do all that, you get x is equal to 5. And you just plug in everything. Ignoring all our sig fig rules, we get 10.4 feet per second. Does anybody remember the sig fig rules? All right. So 10.4 feet per second. Does that make sense? Yes, Anna. Yeah, that's why the trig ones. Usually I would do the trig ones. I'm gonna ask him tomorrow if he wants us. Maybe he'll start them tomorrow. Maybe he just didn't start them today. Because yeah, everyone's the same basically. The trig ones get more interesting because it's the angle that's changing. So you have a trig formula in it, which I know everybody loves doing trig. So it makes it more interesting, I think, because then you can do different types of problems. That's okay. We'll ask him tomorrow. All right, page 154, number 21. A and B. 25. A. And 30. It's angle of elevation. Can't do 39. I'll save that for tomorrow. 21 A and B and 25. I'm going to hand out a sheet as well that has these problems on it. Don't do any ones that involve trig, obviously, until we'll look at those tomorrow. There's half-hour class left. You should be able to get most of the stuff done.